everyone, Sam from Developing Mathematical Thinking, and in this video we're going to look at how to model and describe some place value based methods for addition. And we're going to start by connecting this partial sums that's sort of an expanded form idea to this visual model, and then we're going to look at how these ideas can help us make sense of the standard addition algorithm. So the first thing that I just wanted to make note of is generally when students first start learning to add, their intuition is to want to add the largest place values first, and in addition that actually works pretty well. But if we're going to then start redirecting their thinking to eventually teach them the standard algorithm, that requires us to start with whatever the smallest unit of place value is. In this case, the ones, although if you had decimals, it would be some other unit of place value. So we're actually going to start here with the units of 1 just as a precursor to what we're going to do with the standard algorithm later. So the first thing we look at is our 8 and 3 ones. We add them together. So we have 11 units of 1. And what that would look like visually is we're essentially taking those 3 units of 1 and composing them with the 8. Now we have a 10 here, but for the moment we're going to stick with calling them 11 units of 1, and you'll see why when we get down to the standard algorithm. So then we move to the next larger place value, the 10s, and oftentimes kids kind of get in the habit of just saying 7 plus 4 is 11. A way to maybe still use that single digit idea but make it more place value accurate would be to say 7 10s plus 4 10s is 11 units of 10, and then have kids answer the question, what number is 11 units of 10? And if they don't know it immediately, they can count 11 10s to get to 110. So what that would look like visually would be these 4 10s would be composed over there with those original 7 10s. So we'd have 11 units of 10 or 110. Then we're going to add the hundreds. And so this 100 right here would move over with these hundreds, and we would have 3 units of 100. Now what we're going to do is take those partial sums and compose them back together to get the sum to the problem. So now I've drawn a new place value model. It's a little bit smaller just to fit on the screen, but it basically shows what we've done over here with our partial sums. So now we're going to add all those partial sums together, and this is where we can connect it to the standard algorithm. So the first thing that we can look at is the units of 1. Now visually we've got 11 units of 1, and the language we want to use is to say, oh, if we have 11 units of 1, we've composed a new unit of 10. And that's where in the algorithm, when we add 8 plus 3, we write the digit 1, meaning we have 1 unit of 1, and then that regrouping, that carrying step is actually saying we've composed a new unit of 10. And what you can do with the model now is highlight where that is. So we've got this new unit of 10 right here that we composed out of 1s, and now we can move that unit of 1 down there and show that we have 1 unit of 1 left over, and that process is exactly what we just did in the algorithm. So then let's move over to the 10s. We have 1, 7, and 4 units of 10. So it ends up that we actually have 12 units of 10 now, and in the standard algorithm we're going to write the 2 10s, and then we regroup that new unit of 100, and the language ends up being the same, that we've composed a new unit of 100. Well, just like we did in the last process with the 1s, we can try to look for where is the 2 units of 10. Well, we've got 2 of them here, so these 10 units of 10 are where that 100 that we composed came from. And again, we describe it as composing a new unit of 100. And then if we put those partial sums back together, we can see that when we started with only 300s, we actually end up with 400 because we got that extra 100 from the 10s. So this is how we would model the place value methods first, and then using that process that I just showed here is how we would connect these ideas to teaching the standard algorithm. I hope this video was helpful, and if you want to see how this is connected to subtraction, We also have a video on the same idea and the same process for the standard subtraction algorithm.